Hello. In this session, we evaluate synthetic polymers. Welcome. A synthetic polymer is simply a fabricated agent from organic matter through what is referred to as addition polymerization processes. To enable us go through this, I'm going to look at a typical example where we may take ethene, and ethene being unsaturated may combine with another ethene through addition polymerization. And since polymerization is the simple synthesis of small molecules forming a long continuous chain, we discover that when ethene combines with ethene, it forms polyethene. Now, polyethene is a much tougher substance than ethene based on its long continuous nature. How do we apply this substance for effective use? One, polyethene is effectively used in the manufacture of film wrappers and manufacture of plastic bottles for water. Now, this is a good foundation to enable us to understand how polymerization occurs, the different polymers that are fabricated, and their respective application. Remember, ethene is the most basic unit that can be used to polymerize to form a much stronger substance for use. In this case, we are going to manipulate varied forms of ethene and see what is the resultant product and subsequent use. First, we have what is referred to here as vinyl chloride. Now, vinyl chloride combines with vinyl chloride to form polyvinyl chloride, in other words referred to as polychloroethene. Now, the vinyl chloride is a much tougher substance than ethene, than polyethene itself. For this reason, the polyvinyl chloride is used in the manufacture of insulators for electric cables. Two, we use polyvinyl chloride to manufacture safety belts for motor vehicle. Three, we can use it to manufacture glossy handbags for ladies. This is based on its tougher characteristics over what we are referring to as polyethene. So polychloroethene is much tougher than polyethene and therefore has those described applications. Number two, we have what is known as phenylethine. Phenylethine has a common name known as styrene. Now, styrene combined with styrene to form polystyrene, which is a form of synthetic rubber. Now, this synthetic rubber has a varied range of applications, namely, one, manufacture of unbreakable glass, number two, we can use it to manufacture roof tiles and even floor tiles, depending on the degree of hardening. When it is used for manufacture of unbreakable glass, it serves as a bulletproof, and when it's used as roof tiles and floor tiles, it's for decoration purposes. And next, we have methyl methacrylate. Methyl methacrylate is simply a form of an ester, and this ester combines to form perspex, which is polymethyl methacrylate. Now, this polymethyl methacrylate is also an effective substance for a varied range of applications. Namely, number one, we use polymethyl methacrylate to manufacture optical glasses. For example, spectacles. We also use it to manufacture motor windscreens, manufacture of motor windscreens or windscreens of motor vehicle. And you find that we can also use it to manufacture fiberglass, which is used to manufacture hockey sticks. Next, we have Chloroplane. Now, Chloroplane forms the neoprene polymer. A neoprene polymer is tough, non-corrosive, non-reactant, and for that reason, it is used to manufacture pipes for carrying fuels. So, manufacture of fuel carrying pipes. We can also use it to manufacture corks for chemical substances, for chemical bottles. Good. Beyond this, we have what is known as hexane 1,6-dioic acid and hexane 1,6-diamine. Now, when we combine the hexane 1,6-dioic acid and hexane 1,6-diamine, what is formed is nylon. Now, nylon is a tough substance which has a varied range of applications. One, we can use it to manufacture logical ropes, manufacture of synthetic ropes. We can use it to manufacture sporty nets for netball, football, basketball, and the like. We can use it to manufacture fishing nets and any other nylon garment that will be in essence application in textile. So in summary, therefore, we can see that we have a varied range of synthetic polymers which have unique and specific applications that are relevant for daily use. Having looked at this, it will be also relevant for us to evaluate the advantages and the disadvantages of synthetic polymers. So if you allow me, I'm going to look at that briefly. So to be able to evaluate the advantages and disadvantages of synthetic polymers, we're going to see how effective they are manipulable and how effective they are applicable for their varied range of uses. So here we have the advantages of synthetic polymers. Remember, we said synthetic polymers are fabricated or industrially manufactured, and we have their disadvantages. So one advantage is, one, they are easy to manufacture, simply because they are thermosetting. They are thermosoftening. Now, being thermosoftening means when subjected to heating, they melt easily. So they are easy to manufacture because they are thermosoftening. Number three, they are light and portable. Number four, they are non-creasable. Number 5, they are easy to wash and clean. What then are the disadvantages? The disadvantage one is as these forms of polymers, which are synthetic, are non-biodegradable, which means they form plastics which, when disposed as waste, will not decompose naturally and then will become an environmental hazard in form of polluting the surroundings. Now, this is basically because they have long half-lives and long lifespans, which does not enable them to decompose naturally. Another disadvantage is that when burnt, they emit toxic gases, namely carbon dioxide, sulfur dioxide, and even nitrogen oxides. So, in summary, therefore, we could still see that the advantages far outweigh the disadvantages. We only need to be precautious in the sense that these synthetic polymers are non-biodegradable and they are toxic whenever they are subjected to thermal conditions. Now, that has been the evaluation of what we are referring to as synthetic polymers. Remember, previously we looked at natural polymers, and in a nutshell, we can say that polymerization is both natural and synthetic, and these processes are important in preparing and fabricating substances for daily use. Thank you very much, and that is an advantage in the field of organic chemistry.